In today's video, here is a nice problem regarding arithmetic in number 3. Here is the following setup. Our goal, we are going to find the last two digits of this number. We have number 3 as a base, we have 1997 as an exponent. So, meaning of the last two digits, which means when you divide this number by 100, we keep a remainder. That remainder equivalent to the last two digits, okay? Let's go ahead to do this one. So we can do this one in two different ways. We can do it by using the Euler Theorem, or you can use the Binomial Expansion. So if we have GCD of the base A and N equals 1, so A to the phi of N is a congruent to 1 mod N. So this is the general definition for the Euler Theorem. The GCD of these numbers equals 1, okay? 3 cannot divide 100. So now let's calculate phi of n. Phi of n, as a general definition, we have n is multiplied by 1 minus 1 over p1 factor 1 minus 1 over p2 and all the way down to the 1 minus 1 over pk, okay? p1, p2 through pk, p1 through pk are the factorization prime for n. So n can be divisible by p1, p2 or pk, okay? So now let's calculate phi of 100. Phi of 100 equals 100 factor 1 minus, what's the factorization prime for 100? We have a number 2 and 5 because 100 is going to divide by 2 as a prime. Also 100 is going to divide by 5, okay? There is only 2 primes here. So 1 minus 1 over 2 factor 1 minus 1 over 5. So this one is given as 100, is given as half 4 over 5. If I'm going to calculate, this one is given as 40, okay? So I get here the following. I get 3 as a base to the phi of 100, which equals 3 to the 40. This one is a congruent to 1 mod 100, okay, by the definition of Euler Theorem, okay? Now we have determined this one. So we get a remainder of this one is number 1, but we have 3 to the 1997. We are going to work on this one. So we know 3 to the 1997 equals, I'm going to use a trick here, so equals 3 to the 2000 minus 3, okay? I'm going to use a trick in order to transfer this one into this one on this form. So we know 2000 is the same as 40 is multiplied by 50 is multiplied by 3 to the minus 3. I'm going to put this one separately. So 3 to the 40 it will be written on this form. To the 50 is multiplied by 3 to the minus 3. So I'm going to replace this one with number 1. Is a congruent to mod 100. So this one is a congruent to 1 to the 50 is multiplied by 3 to minus 3 is a congruent to 3 minus 3 mod 100. Here is a problem. How gonna simplify this one and find out the appropriate value of this one, okay? Let's use a nice trick here. 201 equals 1 plus 200, which equals 3 is multiplied by 67, okay? Now if I'm going to reduce this one to mod 100, you get this one is a congruent to mod 100, okay? Which means I get 1 is a congruent to this one mod 100. So now also, so I get here 1 is a congruent to 3 is multiplied by 67 mod 100, okay? I'm going to raise both sides to the 3 as an exponent, okay, on both sides. Then I'm going to take the inverse of this one. I'm going to work with the inverse. So I get here 3 to the minus 3, because I'm taking the inverse of this one, is a congruent to 67 cubed mod 100, okay? We know 67 cubed equals, we know 67 cubed equals 100 minus 33, all is raised to number 3 as an exponent. Okay, so if I'm going to reduce this one to mod 100, so get the one, I get this one 0, I will be left with minus 33 all to the cube like this. Okay, I'm going to calculate this one. It's giving us 35 9 37. Okay, with minus sign here, because if I'm going to reduce this one to mod 100, this one is giving us, I will be left with minus 37 mod 100. Okay, now adding 100 it gets me back to 63. 100 minus 37 is giving us 63 mod 100. So this is the last two digits. We found the last two digits equals 63. Okay, so I'm going to use the binomial expansion. It will be more easier than Euler Theorem. So let's do that. So you know, I'm going to do almost the same thing. We have 3 to 1997 equals 3 to the 2000 minus 3. So this one, I'm going to split this one. I'm going to split this one into two parts. I get 3 to the minus 3 factor 3 to the 2000. Okay, so I'm going to leave this one as it is. I'm going to take this number and work on it. So I get 3 to the 2000, which equals, so I'm going to use a nice trick here. So 3 to the 40 is the same as 3. 40, we know 40 is 3 to the 4, all is raised to the 500, because equals 4 is multiplied by 500. So this one is giving us 81. 81 is the same as 1 plus 80, all is raised to 500. Okay, so I'm going to use the binomial expansion here. So by putting 1 plus 80 is raised to the n, for example. Let's transfer this one into binomial expansion. So I get here 1 is the same as n choose 0. So the second one will have n choose 1 factor 80 plus n choose 2 factor 80 squared plus n choose 3 is multiplied by 80 cubed and all the way down. Okay, so by reducing this one to mod 100, so we get this one already 0 all the way down, because if you multiply 80 squared is giving us 64,000. Okay, if you reduce it to mod 100 is giving us 0, but we need only this one. So to calculate this one, replacing this one with 500, so 500 choose 1 is the same as 500 factorial all over 1 factorial 500 minus 1. Okay, factorial. So this one is giving us 500 is multiplied by 499 factorial over 499 factorial. So this one will be cancelled out. I will be left with 500 is multiplied by area. 500 is multiplied by area is 0 mod 100. Okay, this is 0 mod 100 all the way down. So I will be left with number 1 here. So this one, so the whole thing is congruent to 1 mod 100. Okay, we found the same thing comparing with the Euler Theorem. Okay, now the rest we already did it, this one. So by the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.